AC over B plus the fraction AC over 1 minus D. How do we solve it? So this is a pretty common Algebra 2 question, actually. And you may or may not see something like this where it only keeps things in variable form, but it's a great way of understanding how fraction simplification works. So right here, if I'm just gonna rewrite the question here, I have AC over B plus AC over 1 minus D. The smaller whiteboard here so you can see it better. So how do we go about solving that? So first thing you want to do is simplify the fraction in the denominator. So I can break this up looking specifically at B plus the fraction AC over 1 minus D. The best thing we can do here for simplifying this is to get everything into one fraction. This is addition, so I'm going to multiply B over 1 minus D. If I do that, I'll have B times 1 minus D plus AC all over 1 minus D, right? I can even multiply this out here, so I have B minus BD plus AC all over 1 minus D. And I'm going to actually go ahead and do that and put back into the original fraction. So that I have AC over B minus BD plus AC over 1 minus D. Now, if we really think about this, this is AC divided by this whole fraction right here. And I'm actually going to put parentheses around it. So yeah, this is basically AC divided by this whole thing. And we know that if we're dividing something by a fraction, that we are going to say AC times the inverse of B minus BD plus AC over 1 minus D. In other words, we are flipping our fraction. So what we really have is AC times 1 minus D over B minus BD plus AC. So now what we can go ahead and do is multiply our numerator by AC. So we'll have AC minus ACD over B minus BD plus AC. You can either leave it like that or we can take out some constants. So for example, in the numerator we can take out a term of AC. So we have AC times the quantity 1 minus D. And in the denominator we can take out a term of B, just for the B minus BD. So we'll have B times 1 minus D plus AC. And the reason we can't do any further simplifications than that is because in the denominator, sure, we have a 1 minus D here and a 1 minus D here. We have an AC here and an AC here. But we have a addition operation in the denominator, which means we cannot simplify this any further. These two are the exact same answer, but this simplifies it even more. You could have technically kept that all the way through, but I wanted to just show you where our variables land there. So the answer to this question here is AC times the quantity 1 minus D over B times 1 minus D plus AC. So yeah, just to put down in stepwise, go ahead and simplify the denominator first. We can do that by just pulling that out and simplifying it to get everything into one fraction, and then we can do fraction division. And since in our numerator we just had AC times our denominator that is now flipped, and now it's just easy operations from there. But you may be wondering, what if we just have numbers and a single variable? Can we do the same thing? Yes, we can. Let me get a new question here. What if we had 1 plus x over 2 divided by 1 minus the quantity 3xy over 2 minus x. And we don't know what that equals yet, but we can go for it. So what I'm gonna go ahead and do here, same thing, focus on this denominator. So in the denominator we only have 1 minus 3xy over 2 minus x, right? So here it's just easy fraction subtraction. If I multiply the 1 by 2 minus x over 2 minus x, then I will get 2 minus x over 2 minus x minus our fraction 3xy over 2 minus x. To simplify that, because they both have the same denominator, we can now go ahead and subtract the 2 minus x from the 3xy. So we'll have 2 minus x minus 3xy. And that's still over 2 minus x. So step 1, that is just from taking this denominator right there, okay, our denominator from right here, and putting it into this form. Now that that is complete, I'm going to go ahead and simplify our numerator here, because we also have a fraction in our numerator. So we have 1 plus x over 2. If I multiply 1 by 2 over 2, which will just give me 2 over 2, I can now add that to x over 2. So I'll have 2 plus x over 2. So this one right here is our denominator. I'll put a D there. And then the second one is our numerator right there. Denominator, numerator. So now if I put back into this form, I have 2 plus x over 2, and I'm putting parentheses around it, over, in parentheses, 2 minus x minus 3xy over 2 minus x. So this is the exact same thing as this here, this whole thing. We just did a little bit of simplification to make things easier. And now look, we're back at the start of fraction division. The only difference is that there's also a fraction in our numerator, but it's the same rule. This guy's going to stay the same, but our denominator, it's going to flip and we can multiply it. So we really have 2 plus x over 2 times 2 minus x over 2 minus x minus 3xy. And for here, remember, our numerators are going to multiply and our denominators are going to multiply. So I have 2 plus x times 2 minus x. That will give me 2 times 2 is 4. And then x times negative x is negative x squared. And then if I add 2x and negative 2x, that's 0, and I can show you here. Recall FOILing, because if I have 2 plus x and 2 minus x, I have 2 times 2. Sorry, you guys can't see that. FOILing, 2 times 2 is 4, and then our x's, x times negative x is our negative x squared. And then if I multiply 2 and this negative x and this 2, we're just going to have negative 2x plus 2x, which is 0. So we're going to have 4 minus x squared. And it's basically the negative of a perfect square, because if I pull out this negative term here, I'll just have, let's see, I'll be left with negative the parentheses x minus 2 quantity squared. So it's basically your same rule of thumb there. Just pulling out that negative. Okay, so we did the numerator, the denominator. Basically, all we're going to do is we're going to multiply this 2 to everything. So we'll have 2 times 2 is 4. 2 times negative x is negative 2x. 2 times negative 3xy is going to be negative 6xy. And technically you could pull out an x there if you wanted to have x times the quantity 2 minus 6y. You could also pull out a 2 there, but I think it would make things messy. Actually, yeah, it would make things a bit messy, especially because up here you can't really simplify things any further, because in front of our x term, we would, in order to cancel out everything, we need that simplification to also come out on both sides. So this is what we are left with. The answer to this here are 1 plus x over 2 all over 1 minus 3xy over 2 minus x is 4 minus x squared over 4 minus 2x minus 6xy. And that is our final answer there. What if we're dealing with, say, a square root or I? Well, we can also do that. Fraction simplification gets harder as you go through mathematics, and honestly that's all Algebra 2 is focusing on that simplification. And in my own experience, I've seen that a lot of students going through Algebra 2 particularly struggle with fraction simplification, especially around square roots, conjugates, and the number I. So let's do simplification with I. So what if I have something like, let's do an easy one. We'll do 3 minus, let's do square root 6 over 2 minus square root 5. We want to know what that equals. So remember, when we do the conjugate, we're really looking at the denominator and we're just flipping that sign. If you recall your quadratic formula, do you remember how it has x is equal to negative b plus or minus the square root? I'll call it uppercase D because it's our determinant, over 2a. Recall that is our quadratic formula, correct? So this right here are plus or minus there, when we're referring to a conjugate, that's exactly what we're referring to, is flipping that sign. So here when we have our 2 minus square root 5, we're looking at changing that sign right there. So let's go ahead and do this. So we have 3 minus square root of 3, 3 minus the square root of 6 over 2 minus the square root of 5. The whole thing about this in layman terms, we do not want rational numbers. We do not want square roots or the number I. We do not want them in the denominator of a fraction. So this is another key step in Algebra 2 that you will learn. You might touch in Algebra 1. It all depends on what your instructor has planned and your curriculum. It will vary, but this is a typical concept learned. So here I'm going to multiply that fraction by 2 plus the square root of 5 over 2 plus the square root of 5. Right? So now I just have multiplication. I'm going to do it to each one here. And the great thing here is in our denominator, because we have a negative and positive, the exact same thing. All we have to worry about is 2 times 2 and the square root of negative square root 5 times square root 5, which is just 5, because a square root times a square root, if the base is the same, then you're just going to get self. And recall that, because a square root, if you're thinking about it in exponent terms, the square root of 5 is also equal to 5 to the 1/2 power, right? So if I multiply it by itself, so times 5 to the 1/2 power, remember that if you're multiplying two numbers with the same, or two exponents with the same base, then their exponents add. 1/2 times 1/2, 1/2 plus 1/2 is 1. So you're just going to get the 5. So what we will go ahead and do here, I'll do the denominator first. So 2 times 2 is 4. We're going to have a minus sign because of the minus square root 5. And then 5 in the denominator, right? And then here we have 3 times 2 is 6. 3 times the square root of 5 is going to be plus 3 square root 5. Oh, sorry, this 6 is supposed to be 5. Yeah, that's 5. Okay, sorry. I wrote down my example wrong. 3 minus square root of 5 over 2 minus square root of 5. Everything else is the same. I was looking at and I looked wrong. All right. And now we can go ahead and do negative square root 5 times 2. So that'll be minus 2 times the square root of 5. Then we have our negative square root 5 times square root of 5, so it's just going to be minus 5. We'll keep things simple now. Maybe in the future I'll go over another one with different bases. But for right now, let's keep things nice and simple. So now we can go ahead and simplify by a lot. 6 minus 5 is 1. 3 square root 5 minus 2 square root 5 is just going to be the square root of 5, because 3 minus 2. And then 4 minus 5 is negative 1. So that's going to go away. We'll have a negative sign out front. 1 plus the square root of 5 which of course is also equal to negative 1 minus square root of 5. And I would get used to writing it this way because technically if you're looking at a rational number, you want to write in the form of a plus or minus b, this will be square root of b, but the same thing goes with your imaginary numbers, a plus or minus bi, right? These two here, that's how you want to write them. So I'd get used to writing them that way, so that's why I'm going to keep in negative 1 minus the square root of 5, which is our answer to that question there. Let's do one with I and call it a video. I know it's going on a little longer. Okay, let's say... Okay, let's say we have 1 minus the square root of negative 4 over 3 plus the square root of, say, negative 25. Right? And we want to know what that equals. So just a reminder that the square root of negative 1 is I. Therefore, the square root of, therefore, negative 1 is equal to I squared. And so forth. If you have I cubed, you're going to have negative the square root of negative 1. If you have I to the 4th power, you're going to have 1. So here we're only going to be dealing with I and I squared here, but just a good reminder. Okay, so conjugates, same exact thing. I'm going to have 1 minus the square root. I can actually simplify this a bit. Minus, if I pull out that negative there, because remember that's the same as negative 1 times 4, so I can just pull out that I. So I'll have 1 minus the square root of 4, which is 2, so 1 minus 2 I. Tack on that I. Do not forget the I. And then in the denominator we have 3 plus the square root of negative 25, so I'll have 3 plus square root of 25 is 5, tack on the I. So this is now our problem. We have 1 minus 2i over 3 plus 5i, which it looks a lot better than it does. We want to change this plus right there to a minus when we do the conjugate. So we're going to multiply this fraction by 3 minus 5i over 3 minus 5i. And the whole purpose of multiplying the original fraction by its conjugate is because, first of all, 3 minus 5i over 3 minus 5i, it's 1. So it's valid. You can multiply anything by 1. It does not change what you have. But it also gets rid of this 3 plus 5i in the denominator, which that's what we want out. We want that I term out of the denominator. So, enough of my rambling. We're just going to be left with 3 times 3 is 9. 5i times negative 5i is going to be minus 25i squared. And we'll simplify that here in a second. In the numerator, we have 1 times 3 is 3. 1 minus 5i is minus 5i. Then negative 2i times 3 is negative 6i. And then negative 2i times negative 5i is going to be a positive 10i squared. Remember in the denominator, because it's the same thing, it's the conjugate, so that minus term, all we have to count on is the 3 times 3 and the 5i times negative 5i, because the 3 times negative 5i and the 3 times 5i, it's going to give you the same thing, but they're going to cancel out because of that negative term there. Okay, right now let's go ahead and simplify. In the numerator, our positive 10i squared is going to become negative 10. In the denominator, our negative 25i squared is going to become a positive 25. Because remember our rules here, that I squared is negative 1, so it's just going to flip that sign. Okay, so we have 3 minus 10, which is negative 7, and then negative 5i minus 6i is going to be minus 11i. That's in the numerator. Now in the denominator, we have 9 plus 25. That's going to be 34. So yeah, we have negative 7 minus 11i over 34. If you really wanted to, you can take out a negative term. So minus goes for the whole fraction, 7 plus 11i over 34. Yeah. And there you go. These are both the same thing, but and then another important note, so in mathematics, I is commonly used for the imaginary number, but if you're in physics, because I means something else, you're typically going to use J here. And it doesn't matter where you put it, but if you're using like a calculator for complex numbers or a computer program, placement does matter. It depends on it. Sometimes if you have it out front, you might have to say J or I times whatever number, or you can leave it number I. Let me specify that. You might have to say like I times 11. We'll say 11, for example, or you might just have to say 11i. It depends on what you're using, but these two, they're exactly the same thing. And then J, it's another notation for a imaginary number, just something to keep in mind. Right, I hope that helped a lot on simplifying fractions. If you have any suggestions, and yes, I'll try and make these a lot shorter, but if you have any suggestions or any specific problems, go ahead and send them my way, and I'll upload them as they come. Thank you for watching. Hope this helped. Bye.